This week on Hangar Talk, engineers accidentally discover a new propeller.
And Enstrom helicopters are back in business.
Van strikes up even more frenzy with some RV-15 updates.
Aircraft registration certificates are extended officially.
Also, Cirrus is standing down. We'll talk about why.
Ian, are you ready to do some hangar talk?
Let's do it.
From AOPA, your freedom to fly. This is Hangar Talk.
1056, turn right, heading 130, contact final 13.
Welcome to Hangar Talk, everybody. I'm Ian Twombly.
And I'm David Toulis.
David, our guest is Earl Lawrence. This is somebody who you've gotten to know over the years, photographing him. He was with EAA and then with aircraft certification at the FAA, and now with an autonomous company called X-Wing.
That's right. And Earl is going to talk to us a little bit, Ian, about automation in aviation and what he thinks the future will hold for automation. And I asked him a little bit more about GA updates. He is a twin Comanche pilot. And also we talked a little bit about aviation fuel. So he's got some good insights on that.
Okay, cool. So we'll get to him in a few minutes, but first we want to talk about a lot of new tech actually in the news this week. The first is this kind of cool prop design that we saw AvWeb report on. You say it really well, much better than I can.
Toroidal props, Ian.
Toroidal, okay.
Researchers at MIT, they did some experimentation and they found this by accident.
I love that.
That is so wild.
That's great.
So someone might ask, what is a toroidal propeller?
Yeah.
And it looks like it's an enclosed surface, not really a disc, but kind of a almost circular surface with some curves on it. I think this is an interesting story. It blows my mind away. Before anything else, I'm going to say this group was not out to find toroidal propellers. They were trying to do research on silent aircraft propulsion using an ion drive, not an EN drive, but an ion drive. I guess I mispronounced it. I got confused because I'm with you.
Yeah, that's right.
All I'm going to say about this is beam me aboard, Scotty.
Yeah, it is cool. It reminds me a little bit of one of those you'll see people draw infinite loop sort of things, or like the infinity sign sort of. Probably not for an airplane. They talk about it. In fact, they show a picture of it being used for a drone, which I think would be, it's probably more likely where we'd see something like that.
That'd be a great application for it.
Yeah,
absolutely.
But you mentioned their work was in less noisy prop design, and that's, I think, probably where it's most exciting. And they talk, apparently these are used on boats as well. And people say when you see videos of these on boats, it's unbelievable how much quieter they are.
How interesting, Ian. I mean, looking to find propulsion within ion drive. I pronounced it correctly that time.
Yeah,
that sounds so Star Wars and Star Trekky, for the future. And but I can appreciate the fact that it would be much quieter because the vortices are sort of distributed a little bit more over a wide area. And that makes sense because the propeller arc, the shape of the propeller is what provides the noise signature, the outer tip. And this is spread out instead of just at the tip.
So, that's we don't really think about the prop as being the noise problem, but when you I think first of all, two things. When you see like a Robinson flyover, I mean, those are basic GA engines, right?
Right.
But what you hear is the rotor blades. You hear maybe a little bit of the engine, but you hear that high whine of the tail rotor and then the lower of the main rotor. And then the T6. I mean, you hear T6 fine. It's like, man, that prop is what you hear really first. So yeah, it could be some pretty significant changes with prop noise reduction. And that's especially important in places like Europe where they have standards for that.
Right. Well, I say that the future might be bright for this type of technology in certain applications, including maybe some of the autonomous aircraft that we'll talk about later in the show.
Yeah.
But if you're not going to beam me up, Ian, I'd say we move on.
All right. So a little closer to reality, Enstrom. We've talked about them a little bit recently because they went through a hard time. They were Chapter 7 liquidation. Company was shut down for a little while. Thankfully, they had a buyer come in relatively quickly. Actually, a guy from the Midwest, helicopter owner. brought that plant back on, and they have just built, actually got their production certificate back, just built the first helicopter post reopening.
Yeah, the 480B helicopter, and Ian and I, we both did a little bit of research on this. You know Enstrom more than I do, but that design was basically made in the late 80s, updated in the early 90s as the 480B.
Mm-hmm.
They got the show back together. They got the assembly line going. They fabricated a new helicopter with some of the parts that they might have had on site, but it was built using components that were procured, machined, fabricated, and assembled right there. And that is
Yeah.
in Michigan, right? Ian, you've
Menominee.
been
Yep.
there.
Yep.
Yeah.
Menominee. Menominee. Yeah.
Menominee.
Yeah. It's on the UP.
And so that's their 255th 480 series helicopter. These are really pretty bad. I'm going to say pretty badass machines right now.
Yeah. We did go for a visit a couple of years ago, just to talk about really how they were doing. They were selling really well at the time. They had a lot of groundwork on the sales team. They had done some foreign contracts. So we got to fly the 480. Really nice helicopter, flies very well. They are incredibly stable. I couldn't believe, you put them in a hover and they've got a little hat switch trim, and it's like you can almost go hands off in the hover. They're so stable.
Now, folks who are not helicopter pilots, this is saying a lot about a helicopter to go hands off. That's I mean, it's unheard of in something smaller like a Robinson. Like if you, from the few lessons that I've taken, I asked the instructor, "Hey, what happens if I sneeze and my headset flies off?" And the instructor said, "You land, then you put on your headset, and then you take off again."
That's right. Yeah, no distractions.
Right.
And it's a cool company. I mean, it was a local guy, Rudy Enstrom. He built the first one kind of in his backyard. He used wood for the main rotor blades. I mean, the company is totally vertically integrated. So a lot of the machinists and everything, they're coming from local places. They're building everything. They're making the plexiglass. They're buying the avionics and the engines, and that's kind of it. They're building all the rest of it. And
so it's a vertically assembled, and no pun intended, but it's it's a vertical company. They are making most of their own componentry. And you said Rudy Enstrom designed this in the 1940s.
Yeah.
And at a initial testing at Michigan Quarry in 1957. Wow.
Yeah. Yeah.
Now they operate on 6 continents. So that's saying something for that company. And when were they bought again after the bankruptcy? Do you recall?
It was only, oh boy, they announced it maybe a month, 2 months later. I mean, it wasn't terribly long. So yeah, and that was only, boy, I'm going back here, maybe 6 months ago. So yeah, it's good to see them back up to speed that fast. I think they were able to rehire a lot of the same folks. And so they if you're going to HAI, they are going to display that helicopter there at HAI, which is great. So looking for good things from them. And
HAI in Atlanta in March.
Oh yeah, cool. Right. That's right. David, all right, the RV-15, we gushed about this thing when it was revealed at AirVenture last year, and now they've given some updates. They've clearly been doing a lot of test work with this because they have a whole laundry list of stuff that is updated now on the airplane, and it just is so cool. It's even more exciting, I think.
It is. Dave Hirschman wrote an update. Dave and I were out there when that RV-15 was unveiled at AirVenture. I think we got, probably the first look at it really in the hangar before it was even rolled out to the general public. So we do have some confirmed numbers and some different specs for that aircraft. Don't forget the aircraft that was rolled out during AirVenture was sort of a proof of concept airplane. It was a flyable aircraft, but a few things were up in the air. Now we know there'll be at least 200 pounds of baggage in a really big cargo area. 900 pounds of useful load. That's significant.
Yeah, it's huge.
At level flight at 140 knots or more. And the capacity to carry 60 gallons of fuel in 2 wing tanks. And it was not set up as a 4-seat aircraft or even really a 3-seat. I think it was now designed as a 2-seat aircraft.
Yeah. So, I mean, you're talking there, boy, 60 gallons times 6, that's 360 pounds. Plus, if you have 200 pounds of baggage, that's a lot of baggage. 200 pounds is a lot of weight. So, you're at 560 out of 900. That's pretty darn impressive. That's almost, well, that's what, a couple 180 pound guys. So, certainly you're going to be able to load that thing up and keep going. They've made a couple other design changes.
Yep.
The flap handle, I think, was kind of it was a little overhead, if I recall, and
It
now it's on.
was. It
Yeah,
was. And then
yeah,
the markings were like 10 degrees, 20 degrees, 40 degrees, and then the oh shit degree.
yeah. That's right. Yeah,
And
the
I know we can't say that on the air, but we just did because it was placarded as such with a Sharpie,
that's right.
and you
It's a
can
quote.
see the pictures if you
Yeah.
go to AOPA.org and do a search.
So that's on the floor now, where people are going to be a little more used to it.
Right.
Wing, they moved slightly aft a little bit, fuselage a little bit longer, landing gear taller, which is amazing. I mean, it was already pretty darn tall on that gear. The engine will move 1 inch forward and 1 inch down. Slope of the windshield is going to increase for better aesthetics. They're going to taper the wing strut for drag. They're looking at about 140, was it 140 knots or miles per hour? I think you said 140 knots. Yeah.
140 knots or more.
Max level speed. Yeah, that's pretty good for a backcountry airplane. So this thing is going to be, it's obviously going to be a huge, huge seller.
And a reminder that it's a high wing airplane. It's a little bit of a departure for Vans, but they didn't say when it's going to be available or how much how much it would cost. And assumably
Doesn't matter.
it's
People will buy it,
they'll be lining up around the
Yeah, it
block
doesn't
for that
matter.
bad boy.
I know. You're right. So yeah, it's still to be determined when we're actually going to see one for real. All right, aircraft registrations. This has been such a major pain point the last 6-8 months. Normally that pink slip you change registrations, buy an airplane, whatever, you get a pink slip, good for 90 days. It's been
Right.
taking 6 months or more to get the
Backlog.
permanent.
Yep.
So you've had to go in and get extension after extension after extension. We've talked about this, that there was a new law that extended that registration to 7 years, from 3 to 7 years. And so now, David, we've got some more details on exactly how this is going to work.
Yeah. So the main thing is that the listeners that are aircraft owners that pay attention to us via the Hangar Talk podcast or lately on YouTube, y'all need to know that you will be receiving in the mail an updated aircraft registration that will update your registration period to 7 years. So in fact, if you have a registration that, say, it was a 3-year registration, you're gonna get a new registration certificate. That's my understanding. And they're going to be sent out in kind of as we're recording this, Ian, in early February. And the backlog will be even less time. We, like you said, right around the holidays, it was so long, it was up to 190 days. It's shortened now to 148 days, to process that information. But for aircraft purchases, FAA will no longer issue letters of extension, and instead, the aircraft registration application, or what we refer to as the pink copy, will remain valid until the applicant has received a registration certificate or a denial notification, which we hope you don't receive. And so that, to me, is interesting, and that should happen within 12 months. So I guess keep that pink copy for at least 11.9 months.
Until you need to call and say, hey, what's going on? So I mean, obviously, with registrations going from 3 to 7 years, that backlog hopefully will come down very quickly.
Yes, it should.
Yeah. So even though they're saying a year, it's like that the pink copy will be good for. Hopefully it's not going to take that long. And I just want to put a fine point on what you said, because I think it's really important. And that is that if you are a current owner,
right,
you can go on there now. You can go on the registry now and see when your new expiration date is, or do nothing and they will send you the new registration and it'll have the new date on it. And they're starting with those that are expiring first. So if you expire this year in the next couple of months, let's say, starting in February, in early February, hopefully you're going to get a letter that's going to, with the registration, and then, okay, now it's going to be your new date 4 years from now. And then each month they're going to send more and more and more until the people probably who have just recently renewed are going to get the letter last. But
so I wonder when I wonder when I'm going to get one, because I applied for a registration. It was like right at Halloween. So I guess I'm kind of at the end of the line, really, because February would be coming first, and then as we move along. So I'll keep my eyes peeled for that, and I'll keep that pink copy available for, I guess, until next October.
I guess, yeah. Hopefully it won't be that long. Yeah. All right. I want to talk last about this story that just came out last night as we're recording this, and that is that Cirrus has voluntarily grounded its own fleet of SR-22 and SR-22Ts that were built between June 21st, 2021 and February 7th of 2023. And that is because there's apparently an issue with that Continental IO550.
And owners of the Cirruses received an email on February the 8th, which is the week that we're recording this podcast.
Yeah.
So that to me says that that happened pretty quick, and
Mhm.
you want to keep an eye out for it. But now this, just to reiterate, this is based on the Cirrus aircraft that Cirrus owns and operates that are
Operates, yes.
at distribution centers and with Cirrus representatives around the country. However, one might assume that it will be more broadened to other owners of Cirruses that have recently bought them between the
Yeah.
2021 and now.
Yeah. So there's and that's a great point because there's no emergency AD, there's not even a service bulletin yet or anything else saying that you have to stand down. However, if the factory's doing it, you can be sure that something is going on. Continental apparently alerted Cirrus to this, and so we don't know exactly what the issue is yet. We haven't been able to find out. Likely it had, it's some parts batch that Continental was manufacturing that went into the engine that they've been having some sort of an issue. We don't know what that is. They did say that they anticipate that Continental will be issuing a service bulletin in the near future. Will that be enough? Is that all that's going to be, a service bulletin? Maybe. We'll see. We know there is no, like we said, no AD, no emergency AD, anything like that. So it's a little bit of kind of wait and see what's going on here. But it's at this point at least voluntary as to whether you want to keep flying your Cirrus if it was manufactured during that time.
And we did get some of that information from Flight Global. And so if Cirrus
Mhm.
owners who are listening to the podcast, if y'all want to go to Flight Global, take a look and see some further details, which I am going to assume that we will all know further details shortly, because Cirrus has led the world in manufacturing of aircraft in that type of category for quite a while.
Yep.
And my guess is that they're going to try to continue to be as transparent as they have been in the past.
Yeah, that's right. I think, in fact, if you extend this to the owner base, I think what AvWeb said that they calculated it's something like 700 airplanes that were manufactured during that period. So it's not insignificant.
Right.
Yep. All right, David. Hey, Earl Lawrence. It's so cool that you got to talk to him. He's doing this work that they're doing with these autonomous caravans and cargo is really cool stuff. And of course, he's got all this background and all this insider knowledge of what happened during the whole fuels issue while he was there and some other stuff. And so,
and the North Sea,
Yes.
basically componentry that we could put into aircraft, like like angle of attack indicator, some of the modern gadgets that we have now that we really depend on,
Mhm.
were ushered through during Earl's tenure as in the certifications branch of the FAA. And he is a twin Comanche owner. He'll tell us a little bit more about that as well.
Cool.
And X-Wing is a company he is working with now, not WingX, but X-Wing. All right, welcome to Hangar Talk, Earl Lawrence. You are now with X-Wing. You're a private pilot. You have a twin Comanche. You were formerly with the FAA Certifications Division. Let's talk a little bit about what you're doing now with automation and autonomy in aviation.
Sure. So I've got a great opportunity right now. I'm working with, as you said, the company called X-Wing. I'm responsible for all of our compliance and quality there. And it's a great organization. First and foremost, we're an air carrier. That's one of the great things. We're a regional cargo operator. We have 35 Cessna caravans operating every day throughout the country in about 15 different states. Doing cargo deliveries mainly as a UPS feeder. They're one of our biggest customers, and so that's a great thing. But we're taking a Cessna Caravan and we've automated it. A fancy autopilot, I like to say, but a fancy autopilot that actually taxis, takes off, cruises, lands. So we have auto land, we have auto takeoff, we have auto cruise. So if you think about cargo pilots today, a lot of early morning and late night operations. They can be kind of, boring and risky actually. And, just developing automation technology to help them all out.
So do you think that will make aviation safer?
Yes.
Okay. And
yes.
how so?
And this is the whole thing. I look at it, autopilots really aren't new. When you look at autopilots, we tend to forget they've been around since just about World War I, the beginning of aviation. They've been around, and we've seen things on aircraft as the aircraft got more complicated. We've been adding automation and pieces of automation, and this is that next step. That's the way I look at it, and that's one of the great things I like about working with X-Wing as an X-regulator is that we're following the rules. We're not coming in and saying change the system or change anything. We're operating within the current aircraft
because
control
of
system.
your past experience. You know what the rules are. You know how to adhere to those.
Right.
I see. Okay.
Yeah, and that's one of the key things. And I think all the pilots out there, like this pilot too, we all care. We enjoy flying, right? But I think a lot of pilots out there also, we have to admit, we kind of like having that autopilot. We like having the altitude hold. We like having, the systems that monitor the engine for us and, single lever controls. And, so yeah, this is taking it to that next level. But that increases safety. So think about an engine out. Our system goes through that POH checklist. Boom, 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 right? It handles everything
and you're not going to
automatically.
forget something like a human might.
It doesn't forget. It doesn't get the checklist out of order. So I hate to admit it because I just love going up and just flying myself. But this is business, and we're talking regional, cargo operations.
Cargo carriers, and mainly at night, a lot of times in bad weather.
Yes. Yeah. Early morning and late night, those are the primary operations. A day of a cargo pilot is not the most exciting. They get up early, oversee the loading of the aircraft. And I'm talking regional cargo, right? There's also the big airliners and things like that. But they get up early. They make sure the aircraft gets all loaded up. They fly for maybe an hour, not even that, 45 minutes to an hour.
To feed to another connection.
To feed to another connection. Okay. They're in a hotel room for 10 hours after that.
Wow.
and then they go back out, load everything up, and bring the aircraft back.
Okay, so that's a job for a pilot.
Yep.
But you're saying the flying is minimal, the waiting around is maximum.
Yes.
So automation is going to change that.
Automation can really help that. So think about if you're a pilot now and the aircraft can do all these maneuvers by itself, you can monitor the aircraft. So think of it a day, like we have a hub in Raleigh. We have another hub in Michigan, another one in Texas, and another one on the West Coast in Oregon. And think of a day if you could remotely monitor all this. You can get up in the morning, you can do a flight out of Raleigh and send that aircraft out and oversee that whole aircraft. And the way our system works is our pilots still do all the air traffic control. So they're the ones talking to the controllers. They're the one handling it. But the aircraft itself is now automated. So you do that flight outbound. Then you can go to Texas, pick up a next flight, do an outbound. Think that we're doing time zone changes here, right? So you could actually be doing the same, a flight at 9, working across.
Interesting. So the pilot themselves will be on the ground, hunkered down, but they can move through the time zones.
They can move
pick up another flight.
That's right.
Operate that. So they're remotely operating that aircraft.
Yeah, and actually they're going to get a lot more flight time on top of it.
I was going to ask you, how can we write this down in our logbook?
Well, the way it works right now, because we're following the existing regulations, we're using existing pilots. Okay, so and cargo. Well, let's admit it. Cargo operations are a flow through. You need about 1,200 hours just to qualify to fly for our air carrier. Okay. And we all know what happens at 1,500 hours. Okay. I think everybody, that's a reminder.
For our listeners, a lot of folks are jumping ship. They're going to the airlines, regionals or big airlines.
Right.
And there are signing bonuses these days. It's very attractive.
Exactly.
Okay. So we got the 1,200 to 1,500 hour sweet spot then for you guys.
Yes.
And so are you looking to fill that mainly? I mean, you want people to stay.
We do. And actually one of the exciting things I think about it is there's a good number of pilots out there that have lost limbs or arms that can't get into a air carrier, carrying passengers or something. It's hard to get that wheelchair up in through there.
The
But
physical disability
right.
is a hindrance, but they've got the
they're
skills.
pilots. They got the
Right.
skills. Think of all of our
Okay.
veterans and things like that.
Yeah.
We are a perfect employer for that. So we're putting these pilots into commercial service, so it's like they can continue their commercial career. It's a great opportunity. So that's another thing. It's a bonus to this, right? That's not why we're doing the technology, but it is a great opportunity. So this really isn't about cutting pilots out of the system. This is improving things. This is the next step in automation.
That's what I was going to ask you. I was going to ask you, as a private pilot, as a GA pilot, with your twin Comanche that you have over in Virginia, how do you feel about that? If it would, sort of threaten the opportunity for other pilots? It sounds like you're trying to augment instead of cut out.
Well, we are. There's something about the human. Right? There's a lot of things that we do that haven't been. We don't have AI on all the aircraft, and we don't have the computers that can do all of our thinking, but we do have the systems to automate all the boring things that are there. Now, again, the human factors folks will come into, well, so now how are we going to keep the pilots awake?
Right.
And there's things that'll evolve and how we'll deal with all of those, because they have to pay attention.
Well, you said each flight is generally about an hour.
Yes, it's not a long flight.
Huh, that's interesting. Now, skipping ahead a little bit.
Sure.
So we're not going to cut folks out. That would be my biggest concern, especially, at AOPA, we want to grow the pilot population.
Yes.
In any way we can. But so now we're going to automate this. We're going to go ahead and automate it from startup to shutdown.
Correct. Yeah. So it's really pretty exciting the way the system works. We have an aircraft now. You can go to our website and check the video, or just go to YouTube.
It's
and
flown.
And we have an R&D aircraft that flies, and it's really kind of unique. So those of you that may have the Garmin app where you can upload your flight plan, think of it that. So we have an aircraft sitting there. We upload the flight plan onto the aircraft. Sure. Okay. And then it starts. Okay. And
now, how does it start? How are you checking? When they're turbine aircraft, you're not really checking magnetics, but how do you start and how are you going
exactly through that? So well, think about a cargo operation. You have ground control. So we've got a marshaller out there, right? Yeah. They're making sure things are clear. Okay. You got to make sure your weight and balance is good, the hazardous materials, right? There's everything for the setup. So you're standing out there, you give the go ahead. Yep. And so you tell the aircraft to start its startup sequence. What does it do? It goes through the POH. It goes through all the checklists. It clears the air. It clears the area. It's got LiDAR. It looks at it, clears the area, starts it up, does all the control checks. Ailerons up, down, and we right now we have a camera that can watch that, but also you have the marshaller, and then the electronics on the aircraft actually knows that all the control surfaces. Think about, if you do have an autopilot on the aircraft, you hit the button that says check autopilot, and it runs through that sequence.
With the servos and everything,
yes.
you're getting that signal feedback.
That's right.
So the pilot operator,
yes.
can still monitor those signals.
Exactly.
I understand.
And if you're, if you have to move, that can be done. Or if you're on a ramp where you can do your run up, it'll go ahead. It'll do the run up. The computer knows whether it's getting a hot start on a turbine, and it knows how to shut. So it is monitoring everything. It never gets tired. It knows every system on board the aircraft. It's monitoring all that.
It's not going to spill coffee on the flight deck.
It doesn't spill coffee on the flight deck. And then when you get a clearance, let's just say we're at a controlled airport.
Yeah.
We talk that the remote pilot talks to the air traffic control tower, gets the taxi clearance. And some of the unique things from a safety standpoint is, the aircraft is, because of the LiDAR systems on board and the camera systems, it's clearing, and it'll stop. It won't run into anything. Yeah. It knows where it can follow another aircraft. It'll maintain distance, just like your cars do now. It's a lot of those same systems. But what it'll do is it will never, for example, cross a runway. Even if you, so let's just say you clear it, and the clearance is, use taxiway Alpha to Bravo, cross runway 1, hold short, hold short of runway 22, right? I made it all up. I don't know what,
Okay.
so it will hold short. It'll hold short at 1 until the pilot says, yes, you are cleared
because
to
you're
cross
getting
that.
the tower is clearing you to cross
Yeah,
that.
right, exactly.
That runway. I
But it
gotcha.
won't ever like mistakenly just go across unless it's actually been cleared.
Well, we had
across
an
it.
incident the other day
That's
in New
right.
York City where a couple of commercial airliners
Yeah.
almost bumped heads. It would have been tragic.
Yes.
So
yes.
it'll avoid that kind of a thing. Are you doing it with when you do that? Is it part of that visual via video link, or is it
No.
via GPS? Or you were talking about LiDAR?
So the aircraft knows where it is via LiDAR. I mean via GPS,
Okay.
and then it's using LiDAR to clear the area.
Explain to our folks who don't know what LiDAR is
Okay.
what it is, because that's
Okay.
it's very interesting. And I also want to mention that I've seen that in use now a lot with drones.
Yes. Well, drones and automated cars that you see driving
Okay,
around.
okay.
You'll see something round and you'll see something spinning around. Well, there's a laser in there.
Okay.
And that's what the L in LiDAR is for. It's a laser light, and it's like radar. Okay, so it's measuring the distances, but with light. It does a 360. Of course, this is aviation, so you have to be redundant. So there's multiple systems of LiDAR that is understanding what's in the area.
So it's looking at a three-dimensional photo. It's actually in three-dimensional area. It's actually building sort of a visual picture of everything.
It does.
What's left, what's right, up, down, front, back.
You've got
Okay,
it. So it's clearing that whole area. And then we're also working with vision systems on top of that. And then the GPS is what is primarily used for the taxiing. Now, there's actually our taxiways are actually surveyed. So people go, well, GPS can be off. Well, yeah, okay.
Yeah.
But the actual taxiways, there's you can buy it as a service now. They're specially surveyed. So that exactly.
It.
So it knows where the center line is, but it's also using a vision system on top of that to double check the GPS. Are we really on the center line?
Well, I've rented some cars recently, and they nudged me into the lane and won't let me go out of that lane. And I was thinking that would be a cool trickle down to aviation. It sounds like it already
That's
is.
what we're doing. So in a way, I don't want to say we're taking car technology per se, but all that learning, those sensors, those markets, we're now making that transition into an aviation rated equipment and hardware and software and everything. And that's the big certification challenge. Obviously.
Well, you have really explained this, because I was at a loss to try to figure out how it would work. And you've broken it down, and I really do understand it. And it sounds like that could be a good opportunity for other folks, like you said, who maybe they've had an aviation career in one facet, and now they want to transition into something else.
Yes.
Now, is there an age limitation on that?
No.
Like there is
well, because it's Part 135,
Okay.
so it's not Part 121 where you have the mandatory retirement.
Okay.
And so, yes, we can bring folks back, and then it's a more scheduled day, right?
Yeah.
So you can come in and do a shift, right? As opposed to because you can hand off aircraft to other people, and I don't want to claim it this way, but you can think of a little bit more like an air traffic controller.
Exactly.
They can hand off an aircraft to the next air traffic controller, and they can switch out, and you don't have to get up in the air to switch out pilots, right? That's a little tough. Or when the aircraft is out at a remote airport, I don't have to have the same pilot there at
someone else can pick it up. Just
somebody
as
else
if
can pick
it was
it up.
a commercial crew waiting. The flight attendants are waiting on another
Right.
pilot crew.
Right.
And it's the same kind of option.
Exactly.
Okay, I kind of understand it. You've broken it down really well. So that is very cool. It sounds exciting. And you don't see it as a threat to GA. We talked about that a little bit.
No. And again, we're having sensors on board that how many of us went, wow, when we started putting our iPads in there and uploading the ADS-B,
Yeah.
and going, wow, I didn't realize all those aircraft around me.
That's
okay.
right. They're all around,
Yeah.
and you with your human eye, you don't see them very
Right.
often.
So we have
Right.
radar, we have ADS-B, so we, actual
Okay.
radar, and these are all compliant to what we call, some people know of the RTCA standards that drive a
Okay.
lot of the the aviation standards and avionics and sensors and things like
Okay.
that. So we, we have all these systems, and so the aircraft actually has. I hate to admit it, but I have to admit it. It probably knows better what's around it, from a situational awareness, other aircraft,
Yeah.
whether they're quote non-cooperative. So if you're in the no radio Piper Cub out,
But
I mean,
happens.
it happens.
Sure.
We know they're there, and it's multiple sensors and backup and triple redundance on the computers, and all the things you need to do for aviation certification.
Well, and then we talk about no radio aircraft like a Piper Cub, or even aircraft that are low to the ground like agriculture ops.
Yes.
I would think that the cargo operation wouldn't really interface with that because you'd be operating at a higher altitude level,
Yes.
unless you're immediately around an airport.
Yeah, that's one of that's one of the unique things that we're doing, at least at the beginning, is we're all IFR operations. So remember, I says, for those of you who are lucky enough to have that Garmin app where you can upload your flight plan and things like that. That's a great thing to have, and that's what we're doing. But it's think about it, we're cleared, so we are not going anywhere unless there's a full clearance to the destination. It's been worked out. We don't even leave the ground until we know, yep, you're cleared to that airport. And again, think about the missions that we have. Generally within around 200 nautical miles, you're talking about, or less, right? You're talking about an hour. You can look at the weather. You can have a pretty good understanding. Now, think about all the weather that's available to both the remote pilot, because now they get all the systems. They don't have to uplink to the aircraft, but we still uplink to the aircraft because we want the aircraft to be smart enough to
know where
not fly into a tornado,
avoid
or
that.
that something
and
like that.
their pilot on the ground also, I was just thinking about this, Earl, they might have multiple screens set up around them, so maybe they can get the bigger picture for looking at the country or the region,
exactly,
versus just your micro photo, which is that 100,
right.
with that 2 hour that 200-mile flight, that 1 hour, that 1 hour in 200-mile flight, 1 hour range.
Yeah, so there's a lot to this, but think about how the systems and the complexity of our systems on our aircraft has grown, and how we've handled that by adding these automated systems on board. And that's really what we're doing here. We're taking it to that next step.
What do you have in your twin Comanche? Do you have, I'm assuming you fly with an iPad mini or something.
I fly with an iPad. Yeah, absolutely. But
you've got probably nice panel mounted situational awareness.
Yeah. I've got it primarily a Garmin radio stack, but I'm old fashioned. I still have the basic 6 round gauges.
Yeah.
I'm still an old school pilot. I still know I learned on round, and I still fly on round. Yes, I've flown, the Garmin 1000s and the 3000s, and I've had some great experiences in my career to fly a lot of neat aircraft and systems. But I mean, I hope it makes some of the old school pilots out there feel a little bit more comfortable that the guy at the, driving the automation flies an airplane with, a basic 6 round gauges, and still knows how to do that.
We're talking about a lot of these eVTOLs.
Yes,
you were involved in some of that as well. I'm still struggling with how that is really gonna work. Any insights?
Well, so there's a couple of things. The transition to electric motors is tremendous. Okay, the advantages, the reliability, the costs. That's everybody knows it's the battery technology or catching up. But the transition to electric is happening. And it's going, that I really see that as a way to do.
Just in cars and motorcycles now, and bicycles.
Well, just from a reliability and a safety standpoint, we're going to move to electric motors. So now it's how that electricity gets there, and that's the race. Now, I really do see battery powered trainers and cargo operations and all that. And I really do see that in the coming years. Absolutely. Now, I don't know how it's going to play out, though, right? Because it'll take some time. I think what a lot of people see in the news, which I do see as a harder challenge, but it is coming, is the urban vertical lift stuff.
Exactly.
So I always say this. I see all these technologies making it and being introduced, but how many new things? So on some of these systems that are being proposed, X-Wing's just working on automation
Understand.
on a conventional aircraft that's
Right.
already type certified, already
Yeah.
has it. Okay, so that piece. So we have other companies that are doing automation, introducing a new power plant,
Mhm.
introducing a new vertical lift technology,
Mhm.
introducing a new market, an urban market. So like
And also challenging some of the regulations.
right. So
Okay.
so as you add all those things up, it just the time period it's going to take to overcome all
I
of those
see.
changes increases, right? So,
In other words, each little piece of that operation is going to take a while to
Yes.
achieve.
Yes.
And so you're adding a building block on one end. You're adding a building block,
Right.
but you've got to build slowly.
Right. And
Okay.
when I was at the FAA and aircraft certification is, leading that organization, I wasn't embarrassed to say it this way to a lot of the companies. I'm your unwanted partner.
Yeah.
Okay.
Yeah.
Because the FAA is there to represent the public.
Yes.
The citizens of the United States of America, to ensure that you're meeting a reasonable level of safety.
Mhm.
And you have to take the agency along the journey. And that's a difficult task. But when somebody at the FAA, everybody that works there takes very seriously what they do, and when they sign their name on something, whether it's a supplemental type certificate, a TC, whatever it is, they truly are. I can hear the lawyers cringing at me now, but they're endorsing your product because they said it meets an acceptable level of safety that is good enough for the United States, and that is a big deal.
It's a hurdle. It's a huge hurdle.
That's a huge hurdle.
Right.
And so every time you have these new technologies, you have a lot of people within the U.S. government, not even just with the FAA, but as the government as a whole, to bring along that journey to convince that new technology not only is safe, but it is of some benefit too.
Safety benefit.
From a safety benefit.
Yeah, that makes sense. And you were involved with a lot of that in the past few years.
Yes.
Okay.
Yes.
Because even just the cockpit technology that we almost take for granted now, like angle of attack indicators, that used to be just such high-priced items, but such an important potential part of the safety package.
That's I'm very proud of that, and I'm glad you mentioned it. We really didn't say much, but for the listeners out there, I started at FAA as what was called the head of the Small Airplane Directorate, and I was the executive over that, and one of the first things we did is get to rewrite the Part 23 regulations,
Right.
But also part of that I got to be part of introducing what we call NORSI, non-required safety enhancing equipment. And that was an important policy change that I'm really proud of the agency of doing it. And that's how we let all these angle of attack indicators and things like that. I was saying, they were available for the experimental guys for,
Indeed.
less than $1,000.
Sure.
And it was costing $20,000 to put on some certified unit. And we're like, there's got to be something in between here and get these technologies introduced. So that, the angle of attack indicator is one of them. But we just look at the wide suite of things that can be introduced. It's been fun to watch just recently. I've seen laser altimeters introduced to GA where you can even strap them onto your struts, and you can tie them into your Bluetooth into your audio panel, and it talks to you and tells you how many feet off the ground you are when you're coming in for landing. And there's some videos out on YouTube
that would
out
also
there.
help keep retractable pilots from forgetting to put their gear down.
Right. Well, yeah, there's that too, and available at Aircraft Spruce and approved as NORSI.
Wow.
So
That's
a lot.
neat.
There's
I
a
like
lot.
that.
The big guys get to have the computer talk to them. Why not the rest of us?
That is
too,
really
so.
helpful. Well, no, it could be a huge safety margin if you're flying a seaplane. There are systems out there now. If you're flying a seaplane, you don't want to land with your amphibian wheels down.
So,
But yeah, North Sea is really, that was a huge step forward. Ian and I have talked about this on Hangar Talk a little bit. I kind of felt like the FAA was more touchy-feely in the past few years than it had been before. When you were there with certifications, ushering through some of these safety items to me seemed like such a good idea rather than have the resistance from years gone by.
Yeah, I don't like to talk, criticize anybody because everybody's focus is safety, right? And sometimes it just takes somebody to ask, is this the safe thing to do? It may be, and we may look at our regulations and say that's compliance, and there's different camps in there. Is safety compliance, or does compliance assist that, and there's other means, additional means that can get us to safety. So safety is always the primary concern.
Absolutely.
It is the gold standard. That's what's all driving us. But I think when you say touchy-feely, I look at it as, no, it's changing the conversation to say, no, what is the safe thing to do here? And one of the discussion items, I got to be involved with introducing what we call the safety continuum. Okay. And really, again, that goes back to safety, and that's how some of these new technologies and these new STCs got released, because the fundamental question is, if we make the requirements too high for a new piece of technology, it never gets introduced. Okay. So there's a balance in there.
Sure.
So if you make it so expensive, nobody comes out with new airplanes, nobody updates anything. So there's that balance where you want to make sure there's a correct number of oversight, and that we're making sure we're meeting a minimum level of safety, but letting these things get out into the field and get introduced. Because we want to continue to improve, like electronic ignition. That's
a great example. Yeah, absolutely. Well, that is going to be a good segue to something that I know you were working on before you left the FAA, and I really want to know your perspective on how challenging it is to get this unleaded fuel initiative across the finish line.
Sure. Yeah. Unleaded fuels is, I'm going to say, not a huge technical challenge, but a huge infrastructure and impact challenge. Because technically, we can make piston engines run on all kinds of things, right? Very early in my career, I got an opportunity. I was at the Experimental Aircraft Association, and I got to be involved in the Autogas STC program, and introducing that. And that's a good example of a large percentage of the fleet can run on autogas, and I'm one of those that says you can safely do that now. But the problems with developing new fuels and everything is the entire infrastructure. We're a very small community. You have a handful of oil companies around or refineries. I'm not going to, say it's just oil, but refineries that have to make this fuel for us. It's chemistry, right? They can make all kinds of chemistry for us, but we need it to be affordable, not just work, right? We need it to be able to be distributed. We got to keep there's safety and liability issues with those companies. You've got Lycoming and Continental and everybody else, and they've got concerns about their products, and they want to make sure that this stuff gets tested in their engine. So it's just, there's so many players and so many interactions to get to where we need to be. Now we're going to move away from leaded fuels, and
we have a date mandate,
and we have a date mandate, and that's going to happen. But I'm always really cautious, because I started working fuels over 30 years ago.
Wow.
And
that's incredible.
I didn't think we were going to be here. I thought we would have changed by now.
Yeah.
Okay. So I'm always very cautious of, this is the good thing in aviation. We're very cautious because safety is number one. So, you don't just do things abruptly.
You can't switch a light bulb.
You can't switch a light
switch on and off.
Exactly.
Because there's so much more to this than what meets the eye. You illuminated a couple of things: distribution, the mixing of the chemicals, the formula, basically. something I really didn't think about, the liability to the manufacturers or
Right.
the engine manufacturers, and then also the airframes that can use it and not use it.
Yes.
So, but now we pretty much have blanket approval for at least one of the alternative fuels.
Well, we have multiple
Well, and
alternatives.
we've got Swift and we got GAMI right now.
Yeah, well, I mean, and I always say, don't forget autogas and 82 UL
Exactly,
and
autogas,
91,
right. Well,
and
good point, Earl.
I mean,
Very good point.
there is a range of fuels out there that can operate, and there's also, depending on the engine, there's engines that can operate on a lot of these fuels and list them on their TCs, that have all these different combinations. So there's lots of alternatives in there. Because of the complexity of our system, you can't go and buy 8087 anymore. And like we used to have all these, you used to have 3 grades, just like everything else.
When I was a young tyke, my dad had aircraft, and I remember one aviation fuel was like dyed red.
Yes, 8087.
And one was green, I think.
Right.
And one was, I guess, maybe still is like blue, but were there other colors?
Oh yeah, purple and So there's a range of things out there, and it's really on what is going to be the one the system is going to settle in on, and that's
the one that the system will accept, that most people will be more comfortable with.
So there's going to be a bit of a when I say competition, and also compromises, right? There's first of all, there's no replacement for lead. Okay.
Right. What does it do that's good for aviation engines?
Well, it inhibits detonation.
Okay.
So that plain and simple. And they're getting quote high, there's equivalent octane numbers and things like that, and how to get higher and all that. But we don't really care about all that. We just want to go fly our airplane and know that our engine's going to be safe, and we're going to be safe when we go fly. And yes, we've got GAMI out there, we've got Swift, we've got a couple of other alternatives that are working with the FAA directly. So there's a suite of them are out there. And I think where we are now is not so much on, is there a fuel? It's which one are we going to settle on that fits everybody's needs. When I say everybody, the entire infrastructure. And remember, this isn't just about the United States.
That's true. That's a very good point.
This is moving the world. And that's like, okay, you think it's hard dealing with the FAA? Think about how we're going to move every country.
Well, you got to go through
worldwide.
EASA for Europe,
Yes,
and then I don't know what the regulation organizations are in Africa or elsewhere.
Yes, once I would say a few of the big authorities approve it, it'll flow through. But we have to bring China along. You're going to have to bring Europe along. As you said, Africa. So it's a dialogue. There's just a lot of work that has to get done. And so that's the stuff that, quite frankly, those of us who fly, we don't care. It's just sort of like, that's why we have AOPA and other,
we appreciate that.
Yeah.
And
that's
been
why.
part of that fuel dialogue for probably 2 decades, at least. And ever since I've been here, I remember one of the first weeks I was here, there was a meeting here at AOPA, and it had some FAA officials as well. And that dialogue has not stopped. It hasn't been front and center, but it hasn't stopped since then.
Yes. Yeah. So, again, depending on where you are, I'm confident there'll be a fuel for everyone to operate. What's that transition is going to look like? I don't know. We've had some difficult transitions. If you look at history, people don't think about this. We went from 100 to 130 to 100 low lead back in the 70s.
Okay.
And when that transition occurred, there were a whole lot of airplanes leaking fuel.
Oh.
And what had happened is the chemistry changed a little bit, and so the seals reacted differently.
Oh, right.
And we had to go through that whole situation. So I'm wouldn't be surprised if we have a few bumps along the way.
Yeah, well, it could happen because even though these different fuels have been tested extensively, they're not all out in the field in some of the rough environments in every single way you could use this.
That's right.
And you're right about the seals. That's a really interesting deduction. And I used to fly a Mooney. I know that that aircraft, sometimes you could put bladders in them. Some of the 182 Cessnas have bladders.
I have bladders in my
airplane.
aircraft.
Have bladders, right? So that we need to see how it plays with that.
And it's not just a material compatibility situation, because think about, many of us, I've changed my bladders, but many people have the bladders that may be 30, 40, 50 years old.
Right.
Okay. So how a new chemical will react to older one. So it could be compatible with a brand new one, and you could put a brand new one in, but an older one, it may,
so I wouldn't have thought of that.
So so those are the kind of things so you're like, why don't they just approve everything? Well, that's the kind of stuff that everybody's working through, because I mean, let's face it, if you have an older aircraft and you have, and you didn't know any of this stuff, you just got into aviation, you're a private pilot, bought an airplane, and now somebody changes the fuel, and now I got this big bill, because I got to go through my aircraft and
people
change
will be
things
unhappy
out,
with that. Putting on that and staring in that crystal ball one more time. How soon do you think we'll get this accomplished, just as a GA pilot now?
I hesitate to pick a number, because as I said, it's almost more of a political process than it is a technical process.
We know we can make it work technically.
We know we can make it technically for the most. Now getting it available to everybody and out there, and that's the hard.
It's a challenge.
That's the challenge.
But right now, when we are using avgas, certain chemicals from that avgas are coming from overseas. And so that really is a hindrance to us. What if something happened to the supply chain?
See, that's my worry, and I'm glad to hear the advocates of the new fuels speaking up to that, because we are reliant on one supplier of tetraethyl lead, the main component. It's only made one place in the world. That's it. One plant. They have a fire tomorrow. That's it. Okay.
GA is not going anywhere for a while.
There's some supply in the network. It doesn't fall apart on day one, but we're gonna, we really need to make that transition. And of course, we know communities are very upset about our lead emissions.
We've seen that in California already.
Exactly.
The rest of a couple of airports. We've talked about that on Hangar Talk.
Right.
And we want to make it so that the public is happy with GA, not unhappy.
Yes.
So that's a key consideration. And for pilots, we want to have that peace of mind that everything's going to work.
Right. Exactly.
I gotcha. Well, we had a great conversation today. You want give us before we wrap up, and we appreciate you coming down, Earl. Give us a website for X-Wing, or how can we follow along with what you're doing in the cargo industry?
Well, xwing.com. Okay. So X-Wing. Okay. All right. .com. I know that you're going to get, if you just put it in the Google search, you'll get all these Star Wars things. But actually xwing.com is our primary website. And if you were to look up automation in a caravan, you'll get a bunch of YouTube videos. And you might see a couple of our competitors. There's a few of those out there as well. And then our primary air carrier for anybody happens to be a pilot looking for a job. And
there you go.
Martin Air. So if you go to Martin Air, and
I love it.
And we're looking for pilots. I think I always find that the irony in that here we're working on automation, and I'm like, we need pilots. We need pilots.
That's great. Well, that's a good opportunity for folks. So martinair.com, xwing.com. And we can keep an eye on the future. Earl, we're glad that you're there. I'm glad you're there helping usher some of this in from your regulatory background, and pushing for some of the stuff that we really wanted to see in GA. That's refreshing to me.
It is. It'll be a benefit to all of us. It's progress. And, I certainly believe, things like Piper Cubs are going to be around forever, because some of us just want to go fly for fun.
Yeah.
And that will continue. To improve the commercial end of the business, we're going to see a lot more automation.
Well, sounds good. We appreciate any final thoughts I didn't ask you about. Is there something that you wanted to get across that I didn't quiz you on?
Well, one thing I just wanted to highlight for all the new innovations and for all of us in aviation, and those who are trying to introduce new things, a colleague of mine at the FAA had brought up something. It's about the trust bank. Okay. And I just wanted to say we're dedicated at X-Wing to building trust with the aviation community, trust with the agency, and we have to get trust with our investors too. So that we can do all of that. But it really is building that trust bank to show that we can operate within the aviation community. And we're dedicated to doing that and doing that well and increasing safety for all of us.
Appreciate you coming by Hangar Talk and spending some time with us, Earl. We look forward to seeing you in the skies.
Thank you.
Okay, David. I respect Earl. He's a smart guy, knowledgeable guy, experienced guy. However, I'm going to put up the red card on him here on this one because I just don't believe that it's going to, first of all, that they're going to be able to sell this career to man pilots. It's a totally different thing. And then also that man pilots will be able to come back and do this in big numbers because I just think that the medical requirements are going to be probably not a lot different than man flying.
Well, you might have a point, Ian, because even if you're controlling an aircraft on the ground with computers and things like that, you still have to be able to see. You still have to be able to hear. You still have to be able to manipulate some of the controls as if you're in an aircraft. So you might have a pretty good point, and I will say the technology might cross over to us one day.
Yeah,
but the jury is out on that. Yeah, we'll have to just stay tuned and see.
All right, cool. That's all the time we have, David. I'm Ian Twombly. Our editor is Austin Hanson.
I'm David Toulis. Don't forget, you can find us at aopa.org/Hangar Talk for the podcast and on YouTube.
All right. We'll see you.
See you next time, Ian.